How's it going, everybody? And welcome back to our Cisco Enterprise series. In this video, we're going to be diving into forming adjacencies with OSPF, and I'm going to go through the laundry list of things to have checkmarked, green boxes, thumbs up, all that good stuff. And then we're going to flip over to our topology with some Wireshark and some debugs, and we're going to walk ourselves through how to form the adjacency. You're going to see it's actually pretty easy to go through, but it's one of those things where once you've done it a few times, it's going to be relatively straightforward to figure out. So without any further ado, let's go ahead and dive into forming adjacencies. So like I mentioned in the previous video, neighbors must agree on attributes to form adjacency. And again, not all neighbors actually form adjacency. Most OSPF configuration problems happen at this stage. So unique attributes include local router ID, local interface IP address, which totally makes sense because you got to be unique. Common attributes: interface ID, hello interval and dead interval, how often we talk to each other, how long we wait before declaring the remote neighbor down. Interface network address must be on the same subnet, unless of course you're using PPP unnumbered link or IP unnumbered address to like loopback 0 or something like that. But we're not going to be dealing with any of that type of stuff right now. Interface MTU, the maximum transmission unit. Network type, how updates are sent across the link, and they must be compatible value, whether it's both sides need to be broadcast or both sides need to be point to point. Authentication, whether it's null, which is the default, so no authentication. Then you have clear text, which is type 1, and then MD5 and SHA. And then you have the IPv6 SPI, or the security parameter index, for an IPsec VPN. Stub flags and other capabilities like opaque, extensible, non-stop forwarding, graceful restart, all that good stuff that goes along with it. The forming of adjacencies itself is actually very, very straightforward. Remember, it's a cost value. So slower bandwidth, higher value. Higher bandwidth equals a lower value. If there are too many retransmissions, they will drop the adjacency. The maximum metric makes the router look bad to OSPF. And so essentially what that means is, if I have a fully developed OSPF environment and I need to do an upgrade on a particular device, say it's a maintenance upgrade, I need to do a code upgrade, or I need to go put a new line card in it, any one of 50 different things that you could have to do for maintenance. Well, what you can do is you can go to that particular router and do the IP OSPF max metric router LSA. And what that does is it advertises the local router LSA, the type 1 and the type 1 LSA is from that router. And we'll talk about LSA types when we get further on down the road. But it'll take all the router LSAs, the type 1 LSAs, and it will advertise them to all the neighboring routers as 65535 and say, don't use this router as transit, route around it. So it's how you take a router out of the OSPF data path. So resulting in OSPF routing around that router, allowing it to be taken out of service. The database. The link state database must be the same on all routers in order for the shortest path first SPF algorithm to work. Original implementation, type of service or TOS routing was available, but the Cisco implementation doesn't support that. So, and then IP OSPF point-to-point disables the DR/BDR election. So just keep that in mind. That is your type 2, number 2 LSA. Media dependencies. OSP behavior depends based on the media. Ethernet versus frame relay versus point-to-point. Different media uses different network types to control how updates are sent, who forms the adjacency, how next hop is calculated, all that good stuff. With broadcast, the default is IP OSPF network type broadcast, default on multi-access broadcast medias. Now you got Ethernet, token ring, and FDDI. Those are all broadcast types. You send hellos and updates as multicast to 224.0.0.5 to all SPF routers. So if we're using the broadcast network type, we're not using that. We're using 224.0.0.6. Performs designated router and backup designated router election. Okay, so it's kind of a repeat of what we talked about up here with how OSPF works, but I wanted to reiterate it again. So what I'm going to go ahead and do is we're going to go over here to router 26 and 27, XR42 and router R60, and we are going to go through and stand up some OSPF. So the first thing I'm going to do here is I'm going to come between, I'll do this on R60, I'll capture on gig 2. So we'll fire up Wireshark, give that a moment to do its thing. And then that should start to see some traffic. It's not going to be much, but it'll be something. And then we're going to pull up this guy right here. And I'm going to scoot down. Actually, I'll have this guy on top. So I'm going to start on R60, which is way over here. Actually, I'm at 27 is where I'm going to do the debug. So I'm going to go type in debug IP OSPF, and there's a couple of different things that you can debug. So I'm going to do the ADJ, which is the adjacency. Then I'm also going to do the debug IP OSPF, and I'm going to say the RIB, and I'm going to specify the local, and I'm going to say the global. Okay, so we'll see how that comes into play. And then I'm also going to do IP OSPF SPF. Now I will walk you through how. Can I be more specific on that? I'll do intra. So I don't need to debug everything. So I'm going to have the debugs running on 27 and stuff like that. So what I'm going to do, when you're dealing with OSPF, just like with EIGRP, when you go to do your configuration, we're first going to type in router OSPF, and we can specify the process ID. Now I said the process ID here will be 1, which is right there. I'm going to type in 1, and I'm going to hit the enter key. Now what's going to end up happening here is I have a whole lot of options. Now one thing that I'm not going to go do through in this moment is go through all these breakdowns, because there's a lot of stuff to discuss. As we go through all the different capabilities, we're going to talk about probably most of these, if not everything. Like segment routing, we're not going to go into. We're not really going to go into. Let's see here. We can talk about prefix suppression as well. We're going to cover most of these. We'll take a look at fast reroute as well. Stuff like that. Discard route. There might be a couple that we don't hit right away, but over time we will. Now, just like with EIGRP, in order to get OSPF to do anything, you need to use a network statement. So you can do neighbor statements. So you can type in neighbor and then whatever the IP address is, say 1.1.1.1, and then you can specify the cost and hit the enter key and all that type of stuff. But so just be cognizant of those things. First thing we're going to do is we're going to type in the network command. And then I'm going to specify here it's going to be 1.27.60.0, and then you have the wildcard bits. The wildcard bits, just like with EIGRP, is going to be 0.0.0.255, meaning I want you to match on the first 3 octets. 1.27.60 is what I care about. Now, if I was just to hit the enter key, it's going to say incomplete. Let me hit the up arrow and do a question mark. Now I need to set the area. Now, we really haven't talked about the area yet, but the area essentially is going to be the flooding domain. How wide is going to be, are you going to allow, or how many devices are you going to allow OSPF to participate in? So whenever you do this, you need to define the area. The area can be defined through a decimal or in the format of an IP address. For simplicity, I'm just going to put in here area 0. Area 0 is your backbone. So OSPF has a hierarchy, and you have area 0 is your hierarchy, is your core, is your backbone. Everything's got to connect to area 0. Think of area 0 as your home room, your home base. At the end of every day, you want to go home, right? That is the goal. So that's the idea here. So you can put hierarchy into OSPF with multiple areas. And we haven't talked about the area border router yet, but that's essentially what that entails. But we'll talk more about that when we get into inter-area routing and things like that a little bit further on down the road. But for right now, area 0 is the only one you really want to care about. So I'm going to do that. Now what's going to end up happening is you're going to start seeing OSPF hello packets. And if I click on this guy, you're going to see OSPF, and you have the header, and you notice that the source OSPF router is 1.0.0.60. And the reason why it's picking up on that, and you can see the auth type is null 0, the auth data is all zeros. If I pull this back up, the advertising router for this guy, if I do show IP interface brief, is 1.0.0.60, right? I have a loopback address assigned, right? So what I'm actually going to do now is I'm going to come in here and type in the router ID is going to be 1.0.0.60. Now it's been hard coded. Now, if I was to change the loopback address on this device to be something else, what you would end up seeing is that wouldn't change the router ID, right? It would keep it the same. Now, what I'm going to go do is, now that I've typed in that, and I've typed in the network command, I'm going to jump out of global config, and I'm going to do the show IP OSPF interfaces and brief, because I want to see what's configured. So right now, we have gig 2 is enabled for OSPF. It's in process ID 1. The area is 0. The network is this. The cost is 1. The designated router is set to DR. Now we go over to R1 or R27. I type in router OSPF 1, and remember the process ID is locally significant, so you don't need to have that to match everywhere. But in most cases, everybody's going to use the same process ID. And I'm going to type in the do show IP interface brief, and I'm going to set the router ID, because if I just type in the network command, what's going to end up happening is the router ID will become this, because it's the highest loopback IP address. So I'm going to type in router ID of 1.0.0.27. I'm going to type that in, and then I'm going to use the command. It says local rib clear. I'm going to do a network. You'll notice that I've only received hellos from 1.27.60.60, right? I haven't seen anything come from 1.27.60.27. So I'm typing the network command. Actually, let me show you the other way to do the network command. The other way to do the network command is on R27, go underneath interface gig 0/1 and type in IP OSPF process ID 1, whoops, 1, question mark, set the area to 0. That's the same thing as typing in network 1.27.60.0, 0.0.0.255, area 0. Does the exact same thing. So the interface is going up. We can see traffic is going back and forth. We can see a whole bunch of OSPF. And it looks good. So now I'm going to go back over here to R60. It's going through the DR election process. The DR is 60, the BDR is 17. Everything looks pretty good. Now I'm going to go back over to 60. We can see there's an adjacency up. I'm going to go to show run section OSPF. I'm going to go to global config, type in router OSPF 1, and type in network of 1.0.0.60, 0.0.0.0, area 0. Now you're going to see a link state update go across. 27 should get a type, and I'm going to walk you through this. It'll take a little bit of time. And so we have SPF run, and then if I jump out of global config, give that a couple seconds, and then do a show IP route, we're going to have one OSPF route right there. All right, so let me go ahead and do an undebug all, and then I'm going to stop the Wireshark capture. So if we come in here to the link state update, we're going to see the header doesn't have any information, but the link state update is going to have a type 1 LSA. It's a router LSA. And that advertising router is 1.0.0.60. And if we look down here, scoot this guy over just a little bit, you're going to see that it's a type is stub because it is not connected to anything. And then a link type 3 connection to a stub network. And then transit link is this guy because it is a connecting two routers together. So that's what that looks like. Now I'm going to go back over here to the router and I'm going to go full screen because I'm going to walk you through all of this. So there's not a ton. Surprise! You might be surprised, but there's not a ton of information here. So what's going to happen in here is you have the interfaces coming online, two-way communication with 1.0.0.60. I sent my hello out with my router ID. They sent a hello out with their router ID. I see their router ID. Everybody's happy. Backup scene event before wait timer. DR BDR election process kicks into play, right? So we hit two-way. We immediately go into the exchange start. We elect BDR 1.0.0.17. I elect DR. They go back and forth, right? So they say the DR is going to be 1.0.0.60. We didn't set that. That's just what was negotiated because the higher router ID is always going to win. Neighbor 1.0.0.60 is preparing a database exchange. Send database descriptor packet to 1.0.0.60 with sequence number 0 by B06 with option code 52, flag 7, link 32. What exactly that means, that's like, I'm not really sure. It's just OSPF information. So receive database descriptor packet, back in. The MTU is 1500 and the state is an Xstart. Data neighbor negotiation done. We are the slave. So the master slave election process took into play. So we are good to go. Now remember that the master slave process is only done for sequence numbers. It's nothing more. So we have a summary list built, size 1. We're sending information back and forth. We do the exchange. Exchange done with 1.0.0.60. Send a link state request. Send database descriptor. So they're basically asking, have you sent me everything you actually have? Send me your entire database again. So it's okay. So I'm synchronized with 1.0.0.60. I have a full exchange of the link state database. So I'm going to bring up the adjacency. So process ID 1 is loading to done. Now we receive link state request, so it goes through it again. And detect change in LSA type. Remember, we were done, but then I went back through and I advertised through R60. I went through and I did this command right here. Well, this is the response to that. And what ends up happening, and up until this point, there was really no information sent back and forth. So we end up getting receive link state request, and then we detect a change in LSA type 1. Link state ID is going to be 1.0.0.60 from 1.0.0.60 area 0. Begin SPF at whatever time that is. Process time is 7 milliseconds. Running SPF for area 0, SPF type is full. Initializing run to SPF, SPF intra, rebuilding. It is an intra area setup. So it is the router LSA link count 1, and then it goes through all the details of what that is. So creating route for 1.27.60.0/24, path, add path, area 0, all that good stuff that goes along with it. And so this is a network LSA. Router count is 2. So it's that would be a type. It's technically a type 2 LSA because it's a network summary. So we go back and forth, and then we come across, and then we were done. Actually, 1 second. I think, you know what? I was I was incorrect about my earlier statement where up here with this was the initial run. I take that back. We're looking at down heap 12760. That was the initial, them detecting it's a router LSA. Type 2 LSA is a network summary. So we come down here a little bit further, and so let's see here. So everything was good there. It was right. Okay, so we had a new route come in right in here. So we detect, okay, right here. This is it right there. SPF. So detect change in LSA type 1, LSI ID here is this guy. It comes down and then where is it? I'm looking for a type right here. There it goes. It's coming through and creating route right there. 1.0.0.60/32, and then it creates the route update succeeded, adding it to the routing table, and all the good stuff that goes along with that. So that's how OSPF does its thing. Now what I'm going to do is on 60, I'm going to do the exact same thing. I'm going to jump over here. I'm going to debug IP OSPF, and I'm going to say events. I'm going to say flood. I'm also going to do rib global, and I'm going to do SPF for intra, just like that. And what I'm going to do is I'm going to go over here to 27. I'm going to go to global config, do show run section OSPF. I don't have a network statement globally on R27, so router OSPF 1 network of 1.0.0.17, 0.0.0.0. I'm sorry, 27. How did I must have goofed up the 27 area 0. So now 60 is going to get that. There's a flood. All that information is going back and forth. Local rib, global rib. All right, I'm going to go back over here to 27, and I'm going to set the do show IP interface. I said it incorrectly, so I'm going to type in router ID is going to be 1.0.0.27. So notice how I changed the router ID, but I need to do a do clear IP OSPF process. I'm going to just type in proc. Yes, I'm going to reset all OSPF processes. So I'm going to do that. It's going to take down the adjacency and bring it back up. But my router ID will be different. So now it's going to rerun everything. But my router ID has now been updated because it was 117, now it's 27. And that's reflected by show IP OSPF neighbor. Yep, so right now it's still trying to figure out 27. Eventually the 17 will go away and we're going to see 17 come through, or 27 come through. And it does its thing. There's a lot of information going back and forth, but for the most part, everything should be square. If I do show IP OSPF neighbor, I have a full DR, and I'm the 60 is the DR. If I go back to 60, you'll see that if I do a show IP OSPF neighbor, we're going to see 27. 27 is the BDR. This is always showing you who your neighbor is. So I'm going to do a show IP route, and I'm going to have an OSPF adjacent, an OSPF route there in my routing table. And that is exactly how this whole process comes into play. So not very difficult to understand. There's a lot of detail that goes into it, but as long as you understand what's happening here, then you'll be in really, really good shape as you get down the road further. Now, some people might say, well, this is a lot of information. I don't know how to parse it. Well, this is one of those times where you'll have to read through this to get an idea of what's going on. I'm showing you a lot of stuff that OSPF does in the background, minus or not leaving a lot to the imagination, right? You're able to look at the entire OSPF process, all the back end stuff. You're seeing all of that. You can see it adding the route, adding update, creating route 10027/32. It knows where it's got to go as 1276027. So it knows how to get there because the OSPF process knows that based off doing SPF. So fairly straightforward process, right? Do you have to do all the debugs? No. Would I do this in production? No. I'm doing it because it helps all of you understand what's actually happening. Now let's talk a little bit about the database. We do a show IP OSPF database. It's not very big. Now if I come in here and I look at the router, these are the type 1 LSAs, or directly connected routes, and I hit the enter key, I'm going to have a couple of them. So for router 27, link state ID is 10027. The advertising router is 27. You're going to have a stub network, right? And it's going to have, that's the network in the subnet. The mask is /32. Everybody's happy. Now, if you come down here to the transit network, because it detects another router. So that is the DR's address. This is the BDR's address. And if you match over here, they line up, right? There's really not a whole lot of complexity when it comes to that. Now, if I look at the network one, you're going to see that the 1276060 address of designated router, the advertising router is 10060. So attached router is 60 and 27. So we know we're in good shape there, and that's the entire database. We haven't advertised a whole lot, but we don't really need to. Now I want to make mention of something before we dig in and go any further. Type 1 LSAs, so these guys right here, these guys do not flood beyond the area. So if you have multiple areas, you're going to have type 1 LSAs that stay local to the area. Type 1 and type 2 LSAs specifically stay in the area. Type 3 LSAs are a network boundary LSA, also known as the ABR LSA. That essentially, if we were to look at that's going to be your summary LSA, saying if you want to get to this particular prefix, point yourself to this ABR, and that ABR will know how to get there. We'll talk more about recursion and how to read the link state database when it gets down further down the road, but that's essentially what you need to know in order to get that working. So that's pretty much it, ladies and gentlemen. There's really not a whole lot to it. I'm going to go ahead and go full screen here with Wireshark. Let me scroll up here a little bit. So we had a bunch of hellos going out, right? Not a whole lot going on. It was going to 224.0.0.5, all SPF routers. The header had the information in it, the ABR. I'm sorry, the DR. And then if we come down here a little bit further, we can see that there's passing information back and forth. They didn't know about each other ahead of time, so they had to ARP. Actually, let me blow this up a little bit for you guys. So they had to ARP. Then you see the hello packet going back and forth. Then you see a hello packet coming back. Then you see the descriptor packet, database description, and if we close this out, we have our type 1 LSA. So just so to reiterate, type 1 LSA means it is directly attached to the router that's advertising it. So if you're not sure what router is advertising it, look for the router ID. Link state ID and the advertising router ID usually are the same thing. At least they should be. So in this case here, if you were to expand this out, and I remember I told you about demand circuits and not so stubby area multicast routing. It's not supported here because OSPF multicast isn't actually a thing. That's a type 6 LSA. So just be aware of that. Do not age bit. So those are the ones that you should be worried about. But right now, this is a type 1 LSA because it's advertising what it is. And we can look at, that's the description. This is a description. We have the request, another update. Right, so remember I scrolled down here a little bit to, this is the LSA acknowledgement, going back and forth, that everything's working the way I want it to. So if I come back down here a little bit to when I advertise that update, you notice when I do this, we end up getting a full update. So this is the actual router LSA information that I'm looking for. We have the advertising router. Then we have our stub network. The stubnet, and so this here and this here are your type 1 LSAs. So they're directly attached to router 60. Now if I look at, I wasn't capturing at the time, but if I look at 27, we have, these are type 1 LSAs as well, but this is just a transit subnet because at the time, 27 wasn't advertising its loopback. It was just advertising its transit link between 27 and 60. That is why we only have one type 1 LSA. It's directly attached to 27. Even though 27 and 60 share the same subnet, the same point-to-point connection, that's why you see that. But when we come down here to 27 to 60, we expand. Not that one. This one. When we expand 60, that's why we see the loopback, the stub, meaning there is no connection to another router. You know, this is a user subnet essentially. And how that will get propagated. So that's what I wanted you guys to see in this particular breakdown. It's not very difficult to understand, but it needs to be understood. So I'm going to go ahead and close that out. So that is how you stand up OSPF. So I'm going to stop this because I went through the detail of, like I did with the IGRP. What I'm going to do in the next video is we're going to do it on XR and all the other routers as well. We're going to get OSPF fully operational in this little topology and get that all good to go. And then we'll be able to move on with authentication and things like that and knock out the basics to OSPF. Look at the path selection, how that goes. So if you guys have any questions, comments, feedback, that type of stuff, please leave that in the comment section below. If you haven't already done so, please like, share, and subscribe. And I'll catch all of you fine people in the next video.